Okay. Hello, everyone. It's a pleasure to be here and to be able to present our final results and even our future directions in this area. And I'll be mainly focusing on the vehicular ad hoc network. So what we achieved, and I can start by this. So what we achieved, we have now at this stage a city network. So we have a network of connected vehicles, like this. So we have vehicles connected in a mesh to perform and to be able to have a low-cost way to expand wireless coverage for everyone. And all of you know about the example of the internet access that we have inside the STCP buses, and also to enable the Internet of Things. And we like to improve urban life, so we are transmitting and using the buses, using the trucks, the garbage containers, and cars in the city to transmit information from sensors in the street, to be able to get all this information as Tanya was mentioning. So this is a network that will get, and it will be able to have two different purposes at least. So in the harbor network, this is also one of our achievements, we have a network of connected trucks, cars, towboats, and vessels. So here is a completely different environment. What we have is a closed space with all these elements, and we want to improve the logistics. So we want to know information about where are the containers, which are the containers that we need to get the drivers in the trucks, they need to take where are the ships, and to provide all the logistics between them. And how can we do this? All these elements to form a network in closed space in a city. So what we do is we turn the cars, buses, boats, and trucks into mobile Wi-Fi hotspots. So here the vehicles, they are the elements of the network. This is a moving network. I won't go into detail on how all this work, but you can imagine when you have a network that is made by elements that move. So there are enormous scientific and technical things that we need to solve, and we were able to do it, and we were able to have this network really being used by the users. So this is a great achievement. And we have to manage the real-time and delayed torrent data in a smart way, because we want to make sure that we have the users happy, and we also have the information from all these sensors and cameras arriving at the time. So I'll give you some results. So in terms of the harbor network, we have these trucks, towboats, patrols, vessels, we have roadside units, and we can get, so here in this figure, you can see the several trucks, several roadside units, and how they communicate. So the blue lines are connections that are far away. I would say that we can have wireless coverage range that is more than 600 meters. And we cannot do this with normal Wi-Fi. So we had to develop a new technology that has 10 more times range, and also that is able to work with vehicles that move and enable the network, moving network. We also have this STCP free Wi-Fi that was launched actually 1 year ago. So today is the 25. It was 1 year. It turned 1 year this week. And you can see here. So these are the elements. So these mobile access routers, mobile hotspots, are these elements that we have in the buses, and where we are able to provide all this internet access to the users. So how can this be done? So of course we could just integrate cellular and to have cellular hotspots in the buses, but what we are doing is much different. So we know that Wi-Fi has a small range, and it is difficult to have Wi-Fi in a city and giving connection to the city. So what we've developed is this new technology. So the buses, basically they connect to other buses, they connect to the stations that we have in the city, and we interconnected with the Porto Digital for this. And while they move, they will be always connecting to other buses, to other stations, and they if you are in the bus, you will be able to continue to have internet access without problems, even if you are running, for example, a Skype video. So this is not only the movement, but we have to provide all the mechanisms for this to work while the vehicles move. So there are here numerous research points that we have to address. So in terms of the results, I have here some snapshots, and you will have some videos in some minutes. But so we can gather the information from the city where users get in, where users get out, where are the places, where are the times where we have more affluence. So the amount of information that we can get for this is amazing. So we have these 608 vehicles, these more than 50 roadside units, and we can cover the overall city. Here, this includes some results for you to understand which type of information we have. So, for example, you have here the information of the amount of traffic that we have during the weekdays and the weekend. So you can see during the weekdays it increases, then it decreases during the weekend. And something that is very, very important. So we are not only using cellular for this. So the second graphic, if you see the red bars, so these red bars are the ones related to this new Wi-Fi technology that we developed for this. And at this stage, we are able to offload nearly 40% of the traffic. And even in the city center, you can see here in this figure the map where you have the blue and the very dark blue are the places where you have more than 75% of the connections of the buses through this new technology, not through the cellular. And you know, I refer that we have all these vehicles moving, and for this to work, we need to have very fast what we call handovers. So they connect one bus to the other bus to another roadside units. And here is a bar per hour where you have thousands of handovers each hour that are being performed. And this is scalable, so the network is working with all these elements around. So this is something, as Ron said, so this is the largest one that there is in the world, and the number of challenges were enormous. Addressing what Tanya referred, so the network does not work only for the internet access, but we are also using these buses to collect information from sensors. And Tanya also mentioned this figure. So what happens is that I have a set of sensors in some place, and they are there in this place. And what happens is that every time a vehicle gets into the range of these sensors will connect to the bus, will send their information that they stored to the bus, and then the bus, while it is moving, it will get into access of the fixed stations that we have in the city, and they will collect the information to a server where there we can analyze and provide all these graphics that Tanya mentioned. So how is the temperature, how is the wind, and be able also to group all this information to understand how the city works. And so in terms of times, I have here just some examples on how much time these sensors have to get into touch with the buses. So what is the mean time? And we have several tens of seconds where they get into touch with this bus and can get information. They also take some time to get the information to the servers, and we have to provide means to have differentiation. So there are sensors that need to get information very fast. There are the others that don't really have many restrictions, and we have been working on it. And now I'll talk about present and future, because so we have the network, but what can we do, or what can we do more now in the network? So one of the things that we've been working on, and there is a demo out there, is so I refer to you that so a bus will connect to roadside units as we have there, or to other buses. And we have to manage all these data, or the user's internet access, or the sensor's information. But what we want to do, and this, if you think about a dense environment, we will have so many access points out there. And I refer that we need to have a special wireless for the vehicles, but if we are able to use this special wireless and also the access points that we have out there, so we could, for example, have the internet access of the users going through the more bandwidth, so the connection that have more bandwidth, but we could also at the same time be able to send information to, through the normal access points while a bus is stopped, or while a bus is in a traffic light. So what they've been doing is to enable the vehicles and these mobile hotspots to be able to, at the same time, send its data through different technologies at the same time, and through different networks also. So we want to make the most use of the network. So here are some scenarios, so you can know more if you go there to the demo. We already have security on the network, but we want to really improve it. So we want to make sure that we have a secure network by the start, but at the same time, the security will not have problems on the mobility of all these vehicles. And we want to use the network to do more things. So we talked about the internet access. We talked about the information of sensors. So what we are doing now is to use the network to provide content distribution. So I want to have videos, touristic information, or even some software updates, and how to do this using only the vehicular network. So this is something that we have been working, and we are already testing it on our DTN network. And there is a poster out there. And to finalize, we've been also working on new user driving and station applications. And here I include an example where we have this application that will help on the users, on the people that go into the bus. They can directly validate the user tickets in the bus, and this will also give information on how many people are on the bus, if this bus is full or not, if I should take this bus or not. And at the same time, we have this application, and this is an overall system where we can get information in each station, and in each station I know what are the buses and which lines have buses, and how much time I will need to wait for the specific bus of the specific line. So this is very important for people to really know how much time do they need to wait and which line they should wait for. So which one is the best. So, and I have here, so one thing that we also like to do is to have information when the bus is to arrive, to have some kind of a ping in our mobile phone telling, you know, your bus is arriving in 5 minutes, and even so you are at home and you can hurry up to get into your bus. So to finalize, what's next? So we still have many things to do. So we want to test and to integrate new network technologies, new elements in terms of vehicles and sensors, and new network mechanisms to improve all these networks. So what we have here is a base, is a very great base, but we want to do much more with this. New applications. So now we can finally integrate information from sensors, from people, from vehicles, and to understand everything about the city. So there is large pollution somewhere, but you know, so there are lots of cars there also. So, and lots of people. So we can decide what we can do with it. So to improve logistics, safety, and help. And to provide a very smart coordination of the city. And of course, we cannot forget this, and João already mentioned. So one of the things that is also very, very important is the technology transfer. And João gave the example of Vinium, which is a startup that was built, and I'm also one of the co-founders, that was built to implement vehicular networks around the world and using the network that we have here in Porto as one example to be able to propagate around the world. And I think this is also a very good point, a great point of this project. And I would just like to thank you all. I collected here some names, not all of them, but collected some names because this is a very, very big project and many people helped on this, some of them directly, indirectly, but we have to mention at least most of them on this. Thank you.